Hello, my name is Theo McKay, and my research project topic was A-star pathfinding. So what is A-star pathfinding? Well, it's a method for pathfinding. The basic premise of it is that it involves generating a grid of nodes that it uses to find the cheapest costing path from node to node, from the starting node to the ending target node. The way that it determines the cost for each node is using this function here. So the cost, or fcost, of this function for the current node n is gotten from combining the g-cost, which is the cost from the starting node to the current node n, with the h-cost, which is a heuristic estimate of the cost from the current node n to the goal node. Now, before I go into a bit more detail on that, I want to specify the type of movement that I was using in my project, which is octal movement. The way octal movement works is that orthogonal movement costs 1, while diagonal movement costs the square root of 2, which is roughly 1.4. So for the sake of simplicity, I multiplied these by 10 to get 10 for orthogonal movement and 14 for diagonal movement. So here's an example using the octal movement costs of how the A-star method generally works. So what the A-star method does is it takes your starting node and it reads all of the neighboring nodes and gets the f-cost for those. As you can see, I have here the g-cost in the upper left-hand corner, the h-cost in the upper right-hand corner, and the combined value, the f-cost, in the center for each of these neighboring tiles. As we can see, the cheapest costing node here is this one to the right of start for 48. So then we take this node, 48, which we've identified as the cheapest costing node from start, and we look at its neighbors. Of course, we already have the values for these two and these two, but we did not have the values for these two, so we then get those and find that this is the lower costing node, again with a value of 48. So then we read the cost of the neighbors of that node. Once again, the lowest costing one is 48. And finally, reading the cost of the neighbors of that node, the lowest costing one is, unsurprisingly, our goal node, again with a cost of 48. So this is the final path that we end up getting then. In addition to these features of A-star pathfinding, I also implemented weights into my nodes. This allowed me to assign weighted costs to the different tiles or nodes based on, in Unity, their layer, using a layer masking. So the way that these weighted costs work is that a heavier or a lighter cost can cause certain tiles to appear more desirable for taking the path to, because they don't cost as much to move over. A rough example here shows the most direct path that A-star would normally give it, using mostly diagonals along this route. You would not be the most ideal path in this case because of the sandy terrain here, which makes it cost more than going this lower path, which is solely on the grass terrain, which costs far less than the sandy terrain. And going the upwards route would be even more costly than the sandy terrain because it is longer and goes through swampy terrain. So for the sake of clarity, I'm going to be showing my editor build so that gizmos can be displayed, because I did not have time to implement custom code to create my own gizmos for my build. So here we have a map full of tiles. We have obstacles, and we have different terrain types as well. These are swampy areas indicated by these pools, sandy areas indicated by these sandy-colored areas, and then we have forest areas indicated by these tree tiles. We have the player unit, and we have the enemy unit, which is the ones that our code is going to be moving. So I also have a move value here. As my primary inspiration for doing this project topic was the Fire Emblem series. I kind of took inspiration from the ways they have movement limited to a certain value, which is your per turn movement. So this is the number of moves that this red unit can make. So had a little bit of a problem there, not entirely sure what caused that. I apologize. So as we can see a bit further away here, certainly won't be enough to make it to it with 10. So that's how far it goes, and leaves that time remaining. Reload the scene. Change this value to simply 1. And then we'll just move 1. Although I can continue moving it by that value of 1 till it reaches its goal. Some alternative maps. So as you can see, I have set the characters to randomly spawn. As you can see, each node along the path, it's mostly avoiding going through the sand because of how expensive it is, or through the swamp. Of course, here it can't avoid going through the forest tiles because the player unit is in a forest tile. And even here, it's moving diagonal to avoid this singular forest tile. Now, one feature I unfortunately was not able to implement here is this move value cost currently is only reading each node of movement. And although the A-star algorithm that I implemented does take into account the different terrain types like the sand, forest, and swamp, this move value unfortunately does not take in that value. If I had more time to work on this project, that would be my primary focus, would be trying to implement this move value to function with the terrain types. So that, say, moving through one square of the sand tile, of the sand terrain, would cost 2 as opposed to moving through these normal tiles, which would only cost 1 of your move value. Alright, here are my sources, and that is it. Thank you.